All right. Wow. I wonder how long this is going to last. Today we're talking about factoring. Some of you guys probably are already pretty good with this. Um, so let's get rolling. Right away, the first thing I'll talk about is the greatest common factor. So let's just do like a couple little practice ones. Like, all right, ready? Greatest common factor of 20 and 15. Three is not correct because 3 does not divide 20 evenly, right? So it's not a factor of 20. Yep. 5 is good. 5. All right. Greatest common factor of 175. No, I'm sorry. 175. 25. Good, because they both are divisible by 25 evenly. All right. So that would be the greatest common factor. So that's what we're going to talk about today, are using the greatest common factor to essentially what I like to call undistribute. And then we also will be factoring trinomials, binomials, perfect squares, so on and so forth. Let's get moving along. First problem asks us to factor out a greatest common factor of two expressions. They're like monomial expressions, so one term. So the greatest common factor of 18g squared and 27g cubed. All right, well, let's see. I don't know what happened to my colors up there. That's sweet. Oh, I guess they're just not activated. 9, someone said 9, good. So 9 is a factor of 18 and 27, and I believe it's the greatest common factor. Do you agree?
Yes.
And then they also have variable parts, g squared and g cubed. So in this case, they would both have two factors of g, or in other words, g squared in common. So 9g squared would be the greatest common factor. All right, I'll show you just a little bit more on that. So if I just move this down and I just show you a little bit of how and why. Let's say we have, let's say we break up 18 into 9g squared. And what else do I need to multiply 9g squared by to get 18g squared? So like 9 and 2, 9 times 2 is 18, and g squared times 18 is 18g squared, right? So those are two factors, 9g squared and 2. 27g cubed has a factor of 9g squared and 3g. So if I multiply 9g squared times 3g, I get 27g cubed. So therefore, you hopefully can see that the greatest common factor is 9g squared. Right? What about 12x squared and 28x cubed y squared? Well, look at that. Look at the coefficients or the number part. 12 and 28 have a greatest common factor of, I believe, 4. So that would be a 4. And then if you look at the variable parts, this one has, and you can kind of think about it as like, oh, let's break it all down. X times X. This one over here is X times X times X times, I think I said 3X's, times Y. Right? So how many X's do they have in common? 2. Do they have any Y's in common? No, because 12x squared doesn't have any. So the greatest common factor for number 2 is 4x squared. Is that clicking? So what we really use that whole concept greatest common factor for is, like on this next slide, we're going to factor out a common term from a polynomial expression. It might be a binomial, which is 2 terms. It might be a trinomial, which has 3 terms. Might have a 4-term polynomial. So we are going to do what I call this undistribute. It's like distributive property in reverse. So undistributing would mean finding a common factor from all the terms and factoring it all out. So think of this as like in parentheses, and think of a common factor between 9b cubed and 5b that we can factor out. So common factor between 9 and 5 is just 1, so that's not really doing much for us, but they do both have a factor of b. So if I factor b out of each term, or I undistribute, it's like distributive property backwards, what would I have to multiply b by to get back to 9b cubed? That would be 9b squared, right? So if I think about what would be left there, it would be 9b squared and 5. So the way to just quick think about if you did it right is to think about distributing it. If I did take b times 9b squared, I would get back to 9b cubed. And if I took b times 5, I would get back to 5b. So you factored out a b. Okay. Next one, number 4. Common factors between 3 and 6. That would be a 3. And they both also have an x. So for this one, I could take out a 3x. So if I take out a 3x, I undistribute a 3x, what would I have to multiply 3x by to get what I had originally? 3x to the 5th, x to the 4th, minus, I would have to multiply 3x by 2 to get back to minus 6x. What do you think? Picking up what I'm putting down here? Okay. If the first term is negative, I always want you to factor out a negative. So even if there's no common factors other than just 1, factor out a -1 because it's beneficial to not have the first term negative. In this case, they both have an x and they both have a factor of 2. So you can take out a -2x. So factor out a -2x, and what you'd have left here is a 6x minus 7. How can you check it? Just distribute, right? If you want to check it, you can distribute. -2x times 6x is -12x squared, and -2x times -7 is plus 14x. Is that what I had to begin with? Yes, it is. So then I can verify that what I did is correct. All right. Next one has 3 terms. Ooh. Undistribute with 3 terms. Can I factor something out of all 3 of those terms? I can factor out a 2 and an x and another x, so x squared, right? So what's left here on this first one, I'm going to have 3 terms left, right? So what's left here is 4x squared, because 2x squared times 4x squared is 8x to the 4th. In the middle, I have 2x, and at the end, I have a -1. All in favor? Say moo. All right, next page. Remember FOIL? Okay. I don't really like FOIL, but I know it's a big deal. When I was in junior high and my teacher was teaching us about FOIL, it was 8th grade, he like made the whole classroom tinfoil everything. Had like tinfoil everywhere. It was just obnoxious. But I remember it. So that was neat. FOIL, remember, is an acronym that stands for, essentially, I should not eat this apple, should I? No, that's going to be bad on film. All right, we're back. So FOIL, I don't really like FOIL. I like to think of it as like double distribute. So take that x times both of those terms and take this 7 times both of these terms. So what you end up with, and I'll show you how it connects to FOIL. I mean, it's the same thing. But FOIL is just an acronym for multiply the first things, multiply the outside things, multiply the inside products, multiply the last products. So it's like FOIL, okay? FOIL. Here's the reason why I don't like FOIL. How would you FOIL this? Don't have enough letters. We don't have enough letters in FOIL to FOIL this. So, but it's a triple distribute. It's the same thing as what we just did there. Right? So all FOIL is doing is really multiplying these polynomials, and you're essentially distributing each term in the polynomial. So I use the word FOIL, but it only works for binomials times binomials. So in this case, x times x is going to be x squared, x times -4 is -4x, 7 times x is 7x, and 7 times -4 is -28. The two middle terms should combine, and we should have x squared plus 3x minus 28, just like that. Okay, so we're not factoring here, we're multiplying. Multiplying and factoring are kind of like opposites. Okay, if we FOILed this next one out, same thing, double distribute. There. Multiply the 5 by each term, go there. So first term is going to be 3x times 2x is going to be 6x squared. Some people forget the squared for some reason. Some people accidentally add those and get 5x. 3x times -8 is going to be -24x. The inside one is going to be positive 10x, and the last is going to be -40. The middle two combine to make -14x minus 40. Okay, are we good on that? Good. All right. Next slide now, we're going to do that backwards. So I like to call this, I like saying the word FOIL and unfoil. I just think it's limiting. So factoring these trinomials, I also like to call this or refer to this as unfoil. All right, so we're going to do what we just did, but backwards. So if I unfoil, I'm going to get a binomial times a binomial. The values here and here come from my first term, and the values here and here come from my last term. If you start out with just x squared, then these are pretty straightforward. It's going to be x and x. It has to be. If the last term is positive, which it is, positive 10, that means that the two red factors have to be the same sign, right? And if the middle term is a positive 7, then both of those terms have to be positive. So I know the signs are plus, plus. And if that last term is a positive, which it's a positive 10, now we're thinking about two factors of 10 that have a sum of 7, which are 5 and 2. So if I put my 5 in there, put my 2 in there, and I check, here's how I check. I calculate my outside products plus my inside products. So if I take my outside products, I get x times 2, which is 2x. Take my inside products, I get 5x, and those add up to my middle term, which is 7x. The colors? Yeah. She said it looks really cool, for the record. All right, let's try it again. Okay, this one we have, again, we have, I'm not going to do all the fancy colors, though, all the time, you know. So right here, we're going to have x and x. The last term is positive again, so the signs are going to be the same. But the middle term's negative, so they have to add up to -8x, so they're both going to be minus, minus. Okay? Two factors of 18 that are going to add up to -8 would be 5 and 3. So I put a 5 there, put a 3 there. It doesn't matter which one goes where at this point because the signs are the same. And then you'll see that my outside products is -3x, my inside is -5x, and that adds up to my middle term, -8x. So I check it that way. I don't check the whole FOIL. Okay, next one's a little different because the last term is negative. So again, we still have a first term of x squared, but the last term's negative. So now I know that my signs are going to be opposite. One's a plus, one's a minus. Okay, so now I got to be a little more careful about which one goes where. And factors of 24 or negative 24 now are going to be not adding up to 2, but they're going to be having a difference of 2. So factors of 24 that have a difference of 2 are 6 and 4. Now you got to be a little careful because we are going to use 6 and 4, but we have a middle term that is going to be a positive, so I need to put the bigger number with the plus. So I put plus 6 minus 4 to make sure that I get my signs the right way. So now when I just double check this, I got a negative 4x on the outsides, I got a positive 6x on the insides, and those add up to positive 2x. Okay, so when the signs are different, you got to be a little careful of what goes where. Last one, x and x again. Signs are going to be different because we have a last term that's negative, so we'd have a plus minus. And two factors of 56 that have a difference of 1 would be 7 and 8. But we want the bigger one to go with the minus because the middle term is negative. How are we doing out there? Any questions? All right. Dave is good. Factor each trinomial into two binomials. Now it's going to get a little trickier because that first term is not just x squared anymore. So there's going to be more possibilities. When that happens, you should always just look and see, can I factor out any common factors? Because sometimes, like if I could factor a 2 out of everything, then it would be an x squared. It would be easier. But there are no common factors in each term besides 1, so I'm just going to have to slug this out with a little guess and check. There are methods to doing this stuff. There's like all these little different methods are kind of, I don't know, in my opinion, they kind of are a little gimmicky at times. And from my experience, I have trouble remembering them when I have to come back to them like next year or something. So I just think this is the best tried and true method. So let's go ahead and see what we get. Factors of 2x squared. Right? That's going to go there and there. So really there's only two possibilities. We have 2x and we have x. Factors of 21 are going to go here and here. Look at Vikings colors. All right, so factors of 21. Now this is a little bit of a I got to be thinking ahead situation. So what would make my outside products plus my inside products, because the last term's positive and the middle term's positive, so they're plus plus. What would give me outside product, inside product that would add up to 17? Let's see. I like 21. I like to start with the middle products from like within, like the middle. Sorry, I should have said factors. Middle factors. Like I'm not going to start with 21 and 1. I'm probably going to start with the ones that are closer together, like 7 and 3. So if I start with 7 and 3, and I'm thinking, all right, well, if I put the 7 with the 2, that's going to give me 14. And if I put the 3 with the 1, that's going to give me 3. And lo and behold, I found the right combination. There we go. All right. And this is why you should do math in pencil so you can erase stuff if you have to do a little guess and check. You don't want to be the scribble monster with your pen. The scribble monster. All right. There are no common factors to factor out, so we just have to get down to it here. Let's see what our signs are going to be. Opposites or the same? They're going to be the same. They're going to be both minus, minus. How do you know they're going to be the same? Because the last term was a positive, and these two factors come from that last term. They're factors of that last term. So if I'm a factor of a positive, the signs have to be the same because a negative times a negative is a positive, or a positive times a positive is a positive. So factors of 9x squared. I'm going to try 3 and 3 to start. Okay, so I'm going to go with 3x and 3x and see if I can't get to where I need to be. I want a 15 in the middle, so if I go, you know what? If I go 4 and 1, I think I got it. Because that is a negative 12x and a negative 3x, and what do those add up to be? Bada bing. Okay, good. You know, you might not always have this easy of a time. You might have a little more adversity, like, oh gosh, I didn't get it right there. Oh man, I'm not getting it right there. Then just see it through. Okay, this next one, there's a little wrinkle in this that I want to remind you of. If the leading term is negative, factor a negative 1 out, even if no other factor besides negative 1 comes out of there. So factor a negative out. Now I'm left with 20x squared. Basically all the signs change. Minus 29x plus 6. It's just easier to factor now. So now I have a negative, and then I have 20x squared, yada, yada, yada. The signs are both going to be minus, minus. And 20x squared, I'm just going to go with 5 and 4 to start. So 5x and 4x. I got to get to 29. You know what? If I put the 6 with the 4, that's going to get me 24. And if I put the 1 with the 5, that's going to get me 5. And guess what, folks? That's all, folks. We're going to have a negative 5x right there. And then wait a minute. Yep, and we're going to have a negative 24x right there. And those add up to a total of negative 29x. So we got it. Yep, check it. Checky check. All right, last page. Almost last page. Close. We're getting closer. Long lesson today. Difference of two squares is a special case. If I rewrite this, you'll probably go, oh yeah. So I'm going to rewrite this. Watch. X squared plus 0x minus 36. Oh yeah. All right, good. So now we have two factors of x squared would be x and x, and then the last term's negative, so the signs have to be different. Two factors of 36 that have a difference of 0. Oh yeah, 6 and 6. Good. All right, guess what? There's a pattern to this when we have the difference of two perfect squares, is that it always factors like this. It always factors as basically the same identical two factors, but one's plus and one's minus. So you can use a little shortcut here. You look at this and you go, oh, hey, Dave, is that the difference of two squares? Well, I'll be gall danged. A squared is a perfect square, and 64 is a perfect square, so guess what? And that's a difference, so this is going to factor like this. I remember this is kind of like a shortcut thing. I remember a and a, square root of a squared is a, and the square root of 64 is 8 and 8, and one's a plus and one's a minus. Oh, yeah. Hey, guess what, though? Let me call it. Hey, time out. Time out. That's my hands going in a T. Time out. Okay? There is not the sum of squares. The special case is not called the sum of squares. It's not. It's called the difference. So don't go using the difference of squares factoring strategy for the sum of squares. It doesn't work. This right here is not factorable. Not factorable. Can't do it. Doesn't work. A lot of people think, oh yeah, that's x plus 5 times x plus 5, right? You even thought of it, and that's good. I appreciate that. So now, FOIL this out. You're going to get x squared plus 5x plus 25, right? And what happens is you have x squared plus 10x plus 25. And we talked about these last unit. These are perfect square trinomials. Remember these? Yeah. I was jumping up and down excitedly for, in case you were wondering at home. Look at half of 10 is 5. 5 squared is 25. Ha ha. So there's no sum of squares. So don't be going and doing the sum of squares. All right? So finish up these difference of squares. 25t squared, is that a perfect square? Oh yeah, that's 5t. All right, so I got 5t and 5t, and I got plus 4 and I got minus 4. Okay, we're going to run out of time, so we got to go fast. This one right here, 9x squared. 9x squared is a perfect square. 3x and 3x. Is it a difference? Yes, it is. Okay, that's 2y and 2y. One's plus, one's minus. All right, let's go. We got 2 minutes. 2-minute warning. Factor completely. These last ones, we got to factor stuff out in order for everything to completely factor. So right here, guess what I can undistribute? A 4, and that's it. So now 4, I can take that out. I got a 25x squared. I got a minus y squared, and guess what that is? Oh, the difference of two squares. All right, I got a 5x plus y, and I got a 5x minus y. Whew. All right, this next one, I can factor out a 2x squared. Take a 2x squared out, undistribute all that. You're left with 4x squared plus 2x minus 1. Okay, I've done this 3 times today. This leftover stuff does not factor, so that's it. Can't do anything more with that. The last one, you can factor out of each one of these a 5x, right? Okay, so take a 5x out of each one of those, and you should always look to do this, factor out a common term. What I have left is 3x squared plus, what is this, 13x minus 10. Okay, is that right? All right, now 3x squared plus 13x minus 10. I'm not sure if that factors. I actually can't remember. So if it does, you would factor it completely, and you would keep going with this. 3x and x, let's see, minus 5. Oh, minus 5, no, plus 5, minus 2. Haha, it does. That is going to be a negative 15x and or a positive 15x and a minus 2x, and that's going to be a positive 13x, and that's completely factored like that. Woo! All right, under 30 minutes. That's it for today. Your homework is a worksheet. All right, keep it real. It's snowing out finally, so let it snow, let it snow, let it snow. Big Dave represent.